So on the topic of the limit, we can categorize this into different types. First of all, for a constant function y equals to f of x, it is equal to a constant value like c. To visualize the graph, you're basically saying that, hey, I have a line that is parallel to x-axis. Slope of this line is equal to 0. It hit y-axis at c, and we call it a constant function. When we ask to find the limit of this function, limit of f of x, as x approaches to a value like a, no matter what that value is on the horizontal line on x-axis, this is always equals to c. For example, f of x equals to 1 is a constant function. If I ask you to find the limit of function f of x as x goes to -2, what's your answer? It doesn't matter where my x going, to the left, to the right, my y value is fixed and it is always equal to 1. Another example for you. Suppose f of x is equal to pi. Pi is a constant function. It's just a number. To find the limit of pi, you can just type pi. Limit of pi as x going to 3, this is equal to pi. The y value doesn't change. So this is for constant function. What if you have a linear function? For linear function, the function y is equal to f of x, which is mx plus b, or y equals to f of x equals to ax plus b. If the slope is positive, the graph is increasing. And if the slope is negative, the graph is decreasing. So increasing line, slope is positive, and decreasing line, slope is negative. To find the limit of these types of functions, you basically use direct substitution. Linear functions, we use direct substitution. What do I mean by that? Take a look at this example, everyone. In this example, suppose y is equal to f of x, and this guy is equal to x squared minus 9. Not x squared, let's just use x minus 9. Then we move to quadratic form. So this is an increasing line. To find the limit of f of x, as x is getting closer and closer to 0, you are basically substituting 0 into this function. You are finding the limit of x minus 9 as x goes to 0. By direct substitution, you get 0 minus 9 or negative 9. This is your y value, which is the limit of this linear function. The same for quadratic function, functions of degree 3, or in general, polynomial functions. So for polynomial functions, they behave like this. Y equals to f of x is equal to a sub n, x to power n, plus a sub n minus 1, x to power n minus 1, plus dot dot dot, a sub 2x squared, plus a sub 1x, plus a sub 0. To find the limit of polynomial functions in general, we just use direct substitution. Limit of polynomial functions, we use direct substitution. A very simple example for you. Suppose I ask you to find the limit of the following function. I have y equals to f of x, which is x to the third plus 8. What is the limit of this function as my x is getting closer and closer to -2? Something easy to work with. Since it's a polynomial function, we have direct substitution. We are finding the limit. My function is x cubed plus 8, and my x is going to -2. By direct substitution, we have an algebraic expression. We have -2 to power 3 plus 8, which is -8 plus 8, or 0. This is my y value, which is the limit of this function. Okay, what if we have other types of functions? How do we find the limit? For quotient functions or rational functions, like f of x equals to px divided by qx. Your very first step to find the limit is direct substitution. Step 1. To find the limit of rational function or rational expression in general, use direct substitution. If it is a number, then that is your y value for the limit. However, if it's not a number, if in step 1 you get 0 over 0 or infinity over infinity, then you need to simplify the rational expression. Then use direct substitution. Okay, perfect. Let's go over multiple examples to feel comfortable about what's happening here. Example. Here I ask you to find the limit of, let me just not add any parentheses right now, x squared minus 6x plus 5 divided by x minus 5 as x goes to 5. Well, okay. In step 1, we're going to use direct substitution. If we get a number, then we're fine. Substitution, as long as it gives us a number. So if I use direct substitution, what do I get? I get 5 squared minus 6 times 5 plus 5 divided by 5 minus 5. Oh, I got a 0 on the numerator, on the denominator. So step 1 doesn't work here. I have to move on to step 2. This is indeterminate form. In step 2, since we got 0 out of 0, we must simplify our rational expression. So in simplifying your rational expression, x squared minus 6 times x plus 5 divided by x minus 5 can be simplified into, this is 6 times x, x minus 5 times x minus 1. Then you divide it by x minus 5, which is on the denominator. You can get rid of the common factor. So this guy is simplified to a linear expression. So the limit of x squared minus 6x plus 5 divided by x minus 5 as x goes to 5 is the same as the limit of x minus 1 as x goes to 5, which gives you 5 minus 1 or 4. This is the y value or limit. Another one, for example, we're interested in calculating the limit of x squared minus 9 divided by 2x squared plus 7x plus 3 as your x is getting closer and closer to negative 3. So this guy in terms can be written as, remember that you're applying step 1, which is direct substitution, all right? So here you have negative 3 squared, which is 9, divided by 2 times negative 3 to power 2 plus 7 times negative 3 plus 3, which gives you 9 minus 9 divided by 18 minus 21 plus 3, which is 0 over 0. So step 1, direct substitution doesn't work for us. It means that we have to move on to step 2 and simplify first. So here we go. This x squared minus 9 divided by 2x squared plus 7x plus 3 can be written as, here you have x minus 3 times x plus 3, and on the denominator you get 2x plus 1 times x plus 3. So you can get rid of this common factor. So you have x minus 3 divided by 2x plus 1. So the limit of x squared minus 9 divided by 2x squared plus 7x plus 3 as x goes to negative 3 is the same as the limit of x minus 3 divided by 2x plus 1 as x goes to minus 3, which in turn is equal to negative 3 minus 3 divided by 2 times negative 3 plus 1, or negative 6 divided by negative 6 plus 1, or 6 over 5. In more interesting cases, suppose we are interested in finding the limit of square root of 9 plus x minus 3 divided by x as x is getting closer and closer to 0. So remember your very first step. In step 1, what are we going to do? We're going to use direct substitution. Sometimes direct substitution work for you, everybody. Some other times, not so much. So here you get the square root of 9 plus 0 minus 3 divided by 0, which is 3 minus 3 over 0, or 0 over 0 in determinate form. So direct substitution doesn't work. We have to apply step 2, which means that we need to simplify the rational expression. In this case, we're going to multiply both the numerator and the denominator by the conjugate to simplify. The rational expression, we multiply the numerator and the denominator by the conjugate of the numerator. My numerator is in radical form. That's why I'm going to use the conjugate of the numerator. So this guy can be written as square root of 9 plus x minus 3 divided by x. The conjugate of the numerator is equal to square root of 9 plus x plus 3, close up the parenthesis, divide by the same thing, square root of 9 plus x plus 3. And then now you just need to do algebra. Here you have a minus b times a plus b, which becomes a squared minus b squared. So this guy in turns is equal to, on the numerator, you have 9 square root of 9 plus x to the second power minus 3 to the second, and your denominator stays the same, x times square root of 9 plus x plus 3. Okay, when you simplify this, you get 9 plus x minus 9 divided by x times square root of 9 plus x plus 3. And this is nothing but x divided by x times square root of 9 plus x plus 3. You can cancel out x and x. So this guy becomes 1 divided by square root of 9 plus x plus 3. So to find the limit of this rational expression as x goes to 0, you're basically finding the limit of the simplified version of it, which is 1 divided by, this is the limit of 1 divided by square root of 9 plus x plus 3 as x goes to 0. So now apply direct substitution. You get 1 divided by square root of 9 plus 3, or 1 divided by 3 plus 3, or 1 over 6.